Hello, everybody. We'd like to welcome you to a 61850 webinar. This one specifically speaks on DER and will be presented by Renee and Nuno today. Renee, will you please progress the slide for me? I just want to give a quick housekeeping. Please use the Q&A button at the top of your screen to submit any questions for the presenters. If you do not have the Q&A functionality, please just put your question in the chat box and we will move it over there for the presenter to see it. This webinar is being recorded. You can find it after the meeting on the 61850 website under the Past Meetings tab. Please allow me up to 24 hours to post it. And this will also be sent via a link to your email after the meeting. You're welcome to use the chat freely for any conversations with other attendees. And now I would like to give the floor to Herb Falk.
If you can progress the slide, Renee. I just want to remind people that we are, between Joel and I, we are the co-chairs for the 61850 user group, and we're trying to provide more content for the industry. And as part of that, we're having a user group meeting in Wendell, North Carolina in October 22nd and 23rd. And the registration is still open. And the registration link you can see at the bottom of the slide. Next slide, please. So today we have two speakers, Renee Troost and Nuno Pereira, when I've bollocksed his name. But besides what you see on the screen, Renee is a C-grade distinguished member and a member of Working Group 10, 17, and 19, and C-grade B5. That's all significant because Working Group 17 and TC57 is responsible for distributed energy resources. And today we're going to learn about how the Netherlands and other EU countries are adopting 61850 for communication to actual DERs. So with that, I will turn it over to Renee.
Yeah, thank you very much, Herb, for this introduction. Yeah, so we will give the presentation together, me, Renee, and my colleague Nuno Pereira. I'm working for Stedin, a DSO in the Netherlands, and Nuno is working for the European Network for Cybersecurity. Actually, I put on my appropriate shirt, I hope. So today we'll tell you something about, of course, 61850, the routes to 61850, especially for the connection between system operator and distributed energy resources. And to come to the key points of this presentation, I would like to showcase you a clear and practical 61850 example reference implementation beyond the traditional substation boundaries. And I think it's also worth it to give you a little bit insight how we work in the Netherlands, our approach, how we collaborate with different parties, and towards a solution for real-time intervention at DR plants. And of course, the collaboration. So some introduction. Who am I representing? So I'm working for Stedin, the DSO, you see on the right top. But we are, as Dutch grid operators, united in what we call Netbeheer Nederland. So that means that's the collaborating grid operators of the Netherlands. And together we make standards, we use standards so that the different customers has the same rules, the same documents in the whole country. That's beneficial for us, but it's important also for the customer itself. Yeah, where we are, the Netherlands, this tiny country here on the map. For some people, it's good to explain where we are. Yeah, some introduction. What's happening in the Netherlands? We have already quite a lot of years some congestion problems in the Netherlands, and this is a picture of of open data, how we call it, where we share with our customers what's the actual grid capacity in our country. And of course, the different colors means something different. If it's red, then we don't have any capacity. And if it's yellow, we have some capacity on some circumstances. And if it's gray, we have enough capacity. So this is the Netherlands, and you see a lot of red. And this map is for the in-feed capacity. So we have capacity problems both at in-feed, but also in consumption of electricity. So we need some solution actually to have more customers connected to our network. And therefore we came up with the missing link, as we call it. And we call that the real-time interface. And that's what we are going to talk about today. And this is something like, on the left-hand side here, we have the system operator, so the DSO. And on the right-hand side, we have the grid connection owner. And in the Netherlands, up to 2 years ago, we only had something like a connection via the market parties. So if we would like to do some congestion management, we only were able to do it market-based and asking the market, okay, do something for us, but we didn't have any in the real-time domain. That means something like a real-time interface, which is a connection directly between system operator and grid connection owner. I will zoom in a little bit on this more on the next slide and what it's about. So on the left-hand side, we have the system operator logic. We call it system operator logic. It can be an active network management system or something like that, which is connected to a system operator endpoint. And on the other side, it's connected to an endpoint of the connected party, of the customer. Of course, it has some autonomous logic. In case of the connection is down, is broken, it should know what to do then. And then it's going to the connected, for example, to a PV plant or a wind park or something like that. We are speaking about this scope and the communication link between system operator endpoint and the customer endpoint, which are two physical boxes right now. This is 6150 point-to-point connection. And in this presentation, we go in depth, in detail about what we do there and how we approached it. Our approach. Yeah, so I think it's worth it to mention that we collaborated with the market from the beginning. It's not always a given thing that you collaborate with the different stakeholders. So usually from the past, and we still see it happening a lot, that system operators, grid operators, that they make their own standards and they say, okay, market, you have to comply with our standard. That's not what we did. We collaborated with a lot of different stakeholders. For example, we call it Holland Solar, so you can guess what it means. Yeah? The Dutch Wind Energy Association and all that kind of stakeholders, how to deal with this thing we have to solve. We did, of course, market and standard research, and we looked to general items such as scalability, technical aspects, cybersecurity, but also implementation efforts. We try, of course, to reuse as much as possible. If there is a good standard, use it. And yeah, out of this analysis, we came out that 6150, of course, it's no surprise. We are in a 6150 user group meeting. 6150 came out as the best suitable solution for this use case. And that was actually our starting point to go further. We also looked around us, of course. We are Europe, and we are not that big, and we have quite some contacts with surrounding countries. For example, in Germany, they already have quite some time already. They call it Steuerbox, which is a tiny box for low voltage connected customers, which is also based on 6150. And they also do scheduling, what is also in the 7-4 standard right now. Yeah, you have also the Netherlands, of course, what we are doing right now. In France, they are doing more or less the same, also a 6150 based solution there. In the past, it was a solution based on serial connections or hardwired connections, but it's also now 6150 based solution. In Italy, the same, also 6150 based solution. And in Japan, actually, they also recently defined also 6150 based solution. So we are not alone. By the way, in Denmark, I didn't mention it here, but they are also working on the same standard. Yeah, probably also worth to mention this. We are located in Europe. In Europe, the European Union, quite some years ago, they thought about, we have something like an energy transition and we need some frameworks to solve the problem and to which can help us. And they made a mandate, and in that mandate is also a model. They designed a model how you can actually design solutions. They made a 3D model, which is based on the y-axis on the component layer, communication, information, function, and business layer. And then you have the domains from generation to customer, and you have also the zones from process to market. And this is a really helpful model. It is used a lot in Europe also. And we use it also to write our specification. So divided in the business, function, information, communication, and component layer. So that makes it very easy for the reader actually to look up, if it's about, for example, information, then I can expect something like logical nodes or communication, and I can expect something like, okay, how should my connection be built up? And that looks like this. Here we have a two-dimensional view of this. This is just one layer. This is the function layer. And here you see the function in the distribution domain with a distribution automation box or an ID, which is actually connected to an RTU. And that is actually then connected to the DER, to the customer DER, which can be connected to an energy management system, but that can also be a RTU box or something like that in between. It depends how they implement it. But this is how we defined it. And here you see also the scope in blue, where we're talking about in our document. Documents, by the way, are all publicly available, written in English, so everyone can reuse it freely. Yeah, as said, 6150 is the basis. It's the basis for communication, data modeling, and engineering, and that are the three main pillars of 6150. And that was also one of the main reasons why 6150 came out as the best solution for this kind of applications also, because it's not just a communication protocol. No, it's way more. We also use, of course, then SCL, substation configuration language, which is it's a file, .scl file. It contains less than 600 lines, so it's not that big. It's a tiny file, and it describes the complete configuration of the interface for both ends. And everything what's written in that file is mandatory. That means that you can configure your device customer side, but also at the system operator side with more or less one click. So you have to configure, of course, your IP address, but that's it. And that makes it a very elegant solution for this kind of use cases. If we look to the specification document, it's a Word document, a PDF document, of course. And in the document, we defined requirements. And in the requirements, we also, of course, write down the logical nodes, which are, of course, machine readable in the SCL file. But this document is human readable, and humans can then, people can look to it and see what we mean with the different data objects, which kind of commendation classes are used, and how they should be used, how they should interpret it. Mainly, it's a one-to-one derived from the 7-4, 7-420 also, Annex 4, where also some special things are written down for our use case. As I told, we have more or less a zero-touch configuration based on the SCL file. Extremely powerful. I made a small screenshot of it so that you can look a little bit what it contains. But you can also download that one for free, and you can look into it. It describes the complete function of the real-time interface. And in practice, it works also like zero-touch configuration. It's just one click. It's just completely interchangeable. It's a mandatory standard from the 1st of January 2024 in the Netherlands. And yeah, of course, it's Dutch. You cannot read it likely, but from the three main DSOs in the Netherlands, some screenshots from their websites where they describe that the customers are the real-time interface is mandatory for DER with a in-feed power between 1 and 50 megawatt. Then I go to a different topic, which is the compliance verification. Because if you connect between a system operator and the customer, of course, the devices should be compliant to our specification and how to deal with that. And I think it's also worth it to tell you something about that, because this is also a little bit atypical. Usually, system operators do testing of devices which are customer devices which are connected to their systems. They do it also in-house. We don't do that. We wrote a compliance verification document, and the compliance verification document writes exactly which kind of test procedures should be followed to be compliant to our specification. Of course, they first need a 6150 conformance statement. That's also the power of a IC 6150 device. If you are conformant, then mainly you have done your homework, and our application is on top of that. That is what we call our compliance verification plan. The customers can, or the vendors, they can look into the market to an independent testing facility, and they can test their devices based on our compliance verification plan. Of course, it should be an independent testing facility, but then they can choose their facility they want. And if it's tested, we get the compliance verification document, fill it in by the testing facility back with a stamp on it or a sign on it, and we say, okay, that one is approved. We list it on our website, and then the customers in the country can order the device from the vendor. So they have to choose something. Yeah, security, of course. Security is highly important. We have...
René, should I get in here?
Yeah, it's
Yeah.
good.
All right,
Take it
okay.
up. Yeah.
So talking about security, and I see there is already a question about that in the chat related with 62351. In the beginning, in the initial measures, no, we did not think of 62351. The real-time interface and this connection between the system operator and the customer or the owner on the other side, it adds risks, or we can see them maybe not as new risks, but as the same threats being facilitated, being also targeting the system operator and the customer devices through a different interface, the interface that we are creating. So of course, we need to address those threats, we need to address those risks, and we needed to address them in a way that it's always a balance between security and between feasibility, between the money you spend, the money you have available, of course. So in a way that it was secure. So we wanted all the quality, as much security as we could get, but also we didn't want to make it very heavy. We wanted to make it as light as we could. And there were three places where we needed to think about the security. One was the communication channel, another was the system operator side, and another one was the owner side. So for the channel, because the setup allowed that, what we tried to do and what we decided to do in the end that we see in the specifications is to have a secure channel between the system operator and the customer systems. So a channel that an attacker, a malicious party, someone that could want to target either side, that they would find it very difficult to attack, to get into. But then inside that secure channel, on either side, you could always have an attacker, of course, compromising one side and trying to get to the other. So we also needed to secure both endpoints. So on the system operator side, the grid operators already apply a lot of measures based on 27001, 27019, 62443. So these are all standards that have been followed by system operators for many years now. And we checked if the measures that were already there applied because of these standards and because of other guidelines that the system operators follow, if they were enough to protect against these new risks or these new threats through a different interface that we were creating. And they were. There were very little changes. If you read the specification, we say something about the firewall, that there should be a firewall enabled. The only protocol being allowed through that firewall is MMS, which is the protocol that René said already, 61850 MMS, that would be used to communicate between the 2 points. And that is the only addition. There is another addition, more on physical side, that the equipment of the system operator being on the customer premises, that they should be separated from the equipment of the customer in another place, in a locked door. But that was also a common practice already, so nothing new there. So as you see, on the system operator side, not a huge new cost. So the same cost that was already there. For the customer side, same thing. We also needed to balance what we were asking from the customers with the risk that we were bringing to their door. Again, most of them were already connected to the internet, connected through other interfaces, other ways. But this was another channel that we were creating. So for that side, because we had a dedicated communication or dedicated communication channel, what we wanted to do was to be sure that they were aware of the new risks, the new issues that they could have, and that they applied hygienic measures such as not having default passwords, changing or updating, patching the systems frequently with a given frequency that we say in the specification also. And also that the training, through awareness, through a training that we developed. Actually, the training, the video, you can see it on the Netbeheer Nederland website. That's another thing that you can see also on the website. But only these, and the last one that I was forgetting, that for the connections with the internet, that this interface that were creating could not have a direct connection to the interface where they would connect to the internet. So they would need to use a jump servers, exchange servers, VPN. So it created the DMZ or something similar to that, that would add a similar security to prevent that communication. But it's not also a lot of effort on that side. And these measures will also be added to the contract that the customers need to sign. But so the dedicated connection and all these measures were in place, but we got back to checking if that was enough, and we found a complication. So the team that was handling the security of the RTI, they found a new complication that we didn't consider before. So if you go to to this slide, exactly, it's there. So the complication is that the customer accidentally or on purpose, because they thought it was a good idea, they can actually connect the right side of the channel that you see there to the internet. Maybe they had a router in hand and they didn't have other interfaces and they just wanted to connect it, and the connection ends up on the internet. And if that happens in enough customers, then the attacker could, being on the internet, being outside, could have access to enough installations and enough accumulated power that if they would try to, for instance, switch them off or switch them on and off and on and off, like this kind of attack, that it could have a big impact in the electrical grid. We could not accept that. We checked if the measures that we already had in place, the other measures, if they were enough to protect the customer against this attack. And the answer was no. So we needed a new measure. And this new measure was provided by TLS, but the measure was authenticating the SO endpoint. So the customer endpoint would need to authenticate the SO endpoint to be sure that any attacker trying to come from the outside through the internet to send a control command, 61850 MMS set point, that would not be possible because authentication would fail, and TLS would provide that authentication. TLS is something that is very common nowadays. When we access a website, we access it normally through HTTPS. If you access websites that are not on HTTPS, then you shouldn't. But for critical infrastructures, for industrial protocols, it's not the same story. Sometimes it's there, or we thought that it would be there, that it would be available, but we were not sure. And because of that, then we had to go through an experiment. We had to go through a POC. René, do you want to pick it up here again?
Yeah, I will pick it up again. So yeah, the TLS, we performed a proof of concept, and because of TLS is not just an out-of-the-box solution. I buy TLS, something like that. It depends on various sub-requirements. For example, how do we deal with certificate management? How do we deal with the different cipher suites which should be or should not support it? Which TLS version do we request? And that kind of things. And what we did is to perform proof of concept, to get the best idea of what is currently available in the market in relation to our aim, to our goal. We defined 3 different implementation variants. Actually, I don't go into detail of all the 3 different variants, but take it for granted. It were 3 different variants, which we tested in a proof of concept for technical feasibility, but also the process and also the business impact. So business impact can be also differ a lot in terms of how you deal with certificate management. The proof of concept, we performed that in the 3rd and 4th quarter of last year, together with MZ Automation from Germany. So they carried out the proof of concept with 4 different endpoints. And yeah, so not a cliffhanger. Already the key results, all different scenarios we defined were possible, but there were some limitations with, for example, key management automation functions, which you can imagine that is not everything is available within every vendor. Of course, all results, like we started the presentation with the collaboration, that it's so important to collaborate and to be transparent. We shared all results in detail with the manufacturers, with their R&D departments. They were, of course, very happy with it because they could also reproduce all the tests we performed. And that means that we also helped them to also increase their R&D speed and so their technical knowledge and skills. So based on these results, the new specification, it's specification version 1.1, has been published on the website, and this specification is now the standard and will be mandatory from the third quarter 26. This looks like a long time, but we need some time for implementation to deal with certificate exchange and all that kind of stuff, which is quite a thing to implement. Something about the TLS setup? Could you take over again,
I'll take it over again. So 61850 MMS would work, and we saw that it worked according to the POCs that we made with 62351, 62351-4, 62351-3. And of course, because the certificate management, managing the keys that are used for encrypting, for checking the integrity of the communications, for the authentication, so all those keys need to be managed. Then we also needed support for the -9, and all of these was verified in the proof of concept. Still, the standards, if we look at them, they specify how it all should work, but they do not specify how the certificates should be managed. For those that are not familiar with this part of cybersecurity, the authentication of a party is always dependent on one very important thing, which is a secret, a key, a password, something that we keep for ourselves, and talking about public key cryptography, but something that we keep for ourselves and that we don't share with anyone else. So that key, we need to, when we are authenticating to another party, what happens is that we need to prove, or the other party asks us to prove that we have that key, that we have that secret, that we have that password. And in order to do that, we are sent kind of a challenge, and we need to sign, we need to do something to that challenge that on the other side, the other party can use a public key to verify that we actually could do what he requested with that challenge. That other key that is used on the other side is the public key. So this public key, the private key doesn't go anywhere, but the public key corresponding to my private key, it needs to get to the other side. And usually this is done through certificates. And those are the certificates that you are using computers right now when you access a website with HTTPS that I was mentioning just before. That, like, the certificates are there. Your computer has a way to check, for instance, that the certificate or that certificate, no, that the site that you are accessing is actually the site who they say they are, because you have the key, the public key that is able to verify that. And that's also what we wanted to have here. So this is the setup corresponding to the solution that was considered the best one after the POC. And what you see here is basically how those certificates get to where they need to be. So starting below, with number 1, we have the customer endpoint on the right, and the customer endpoint is going to have a customer endpoint certificate. So that customer endpoint certificate, you can see the mouse moving. René is moving it from one side to the other. That certificate needs to go to the system operator endpoint side. It can be through, it needs to be through a secure channel. It can be through a website. It can be through somewhere that is made available at the time that this is being set up. But the system operator endpoint needs to receive that certificate, and we will not do the same as it happens in public websites. For instance, in this case, we will pin it to the system in the system operator endpoint. So the system operator endpoint, when the connection is established from the customer endpoint, it will check if the certificate that is being seen through the connection, if it corresponds to the certificate that it is expecting, the one that was received during the setup. So in that way, the system operator endpoint can also authenticate the customer endpoint in an equal effort from both sides. But what we really want is the customer endpoint to be able to authenticate the system operator endpoint. For this to happen, then in number 2, the system operator is going to get a certificate from a PKI infrastructure. So this PKI infrastructure is something that the system operators need to have ready, to have deployed, to have working within their infrastructures. Not all of them have, and they need to deploy this. This adds some difficulty to the implementation of this measure. But remember, this is important. We needed it to cover for that additional risk, that additional complication that I mentioned before. So that certificate is going to be generated and is going to go into the system operator endpoint. The customer endpoint will see that certificate, but how will it know that that certificate is something that it can trust? So like in the case of a website, like you access to your web banking or that sort of thing, then the system operator through point 3 needs to give the root certificate or the intermediate root certificate corresponding to the key, the private key, the secret that was used to sign the system operator endpoint certificate. It needs to give the public one to the customer endpoint. So that's what you see in 3 in the green arrow. It's being given to the customer endpoint. With this, when the system operator certificate is presented through the connection, then the customer endpoint can authenticate the system operator endpoint. It will have the public key. It will ask the system operator endpoint to prove that it has the private key, and that public key will be enough to verify that actually that is the system operator endpoint, the expected one, and everything will work just fine. It's not only the infrastructure costs, so that system operator PKI that you see there above, all of these, the certificates, they will be set up at a moment, but then they need to be managed. And like René said, an output from the proof of concept was that there are some limitations to what the systems can do, the endpoints can do, mostly in terms of the automation of this process. So for your computer, you access a website and you don't need to do much. Maybe in your companies, you access somewhere and you receive like a pop-up asking if you want to trust a certificate of that server, that machine, and you say yes, and you can access. That sort of thing cannot happen here. So, and we don't have the automation that you do, that in those cases it's there to prevent this situation from happening. So there is some manual work involved here that also has some weight, but we in the specification you will see that we made some assumptions, and we think they are secure assumptions, safe assumptions, in order to make this effort as less as it can be. So, René, next up.
Yeah. Yeah, some technical key points. Yeah, 62351 conformance is required. as also 6.150 conformance is required. Also 62351 conformance is required. We currently require TLS 1.2. The IEC conformance document, so the 62351-100-3 is under revision. I think it's already a committee draft, and that will be available soon. Then we also require TLS 1.3. TLS 1.3 is also already in our specification, but it's not mandatory until the conformance document is also there. As Nuno explained, certificate exchange will be managed by a secure customer portal. Yeah, up to now, we told a lot, I think. It's the countrywide standard for all new DER connections between 1 and 15 megawatt. Our aim is also to expand this range slightly more, because now we have only focus on 1 to 50 megawatt, but we have way more to manage, of course. But you have to start somewhere. All system operators require it. It's also very nice that we have a common voice in the Netherlands. All different system operators are speaking with the same voice. We made it all together with a common understanding, and that's really nice. The specification is stable. There are no technical issues. That shows also that the solution we chose for that it was a right choice. And honestly, that is probably also a good specification, by the way. Some lessons learned. So collaboration. I keep saying it. Collaboration is really important. We have all different kind of parties. We also aligned with other countries, and we keep doing that. That's also a reason why we are sharing our thoughts here, because we think that it's important also for customers that they don't have to develop again and again new solutions. No, we try to reuse what's already being made internationally from IEC, and that's also what we get back from the market. They like that. Our aim is for plug and play. Actually, we reached that goal also, that aim, and that's fantastic. 6150 fits the application perfect. And we also saw new vendors coming in this domain. And we are also glad to see that they implemented 6150 quick. And that was also, we are a little bit curious what will happen, but that turned out very well. There are also some open source implementations available. They used that, and that worked also fine. So, in the end, I think a very successful story, and we are still very happy with the direction we chose. If there are any questions, I will look into the chat if there are any open questions, and I will give a hand over again to Herb or Ryan.
There is, I think, one open question that's in the chat, and I think Nuno will need to answer this. What is the maximal certificate duration allowed in your TLS setup?
I was just answering that one, but I will then talk about it. So it's a maximum of 15 years. That is a lot. That sounds like a lot, I know, but it's a maximum, and there's a good reason for that. So for the system operator side, we are going to try still to automate the way the certificates are obtained by the system operator endpoint, but that might not be possible right away because of the limitations we found. So while it is still a manual process, we don't want to keep that value too low. We want to keep to have the option to have it a bit higher. But once we have that automation, then the certificates on the system operator side can just be changed, like with a lower frequency, And on the other side, because the root certificate is there, they will be recognized. There will not be a problem. Additionally, it can be that high because, again, this measure TLS is there to protect the customer side, and therefore for the system operator, it doesn't matter if they're high or not. To authenticate the customer side, then we have the manual pinning of the certificates. So that means that we will trust that certificate as long as no one goes there and then pins it. So that's the certificate which shows. So it can also be 15 years on that side, because if there's any issue, if there's any reason to think that's insecure, then someone will go there and someone will unpin it. It's related with the second part of the question, if there is automatic CRL checking or not. There is not, because to have automatic CRL checking, we would need to allow the endpoints to connect to other systems, and that is not allowed. So these systems are isolated. That is the system on the system on the grid endpoint side, or the side. It's isolated. We don't want it to be able to access anything regarding the expiration of the customer that would be online or something like that. So any checking would need to be local, and that's why we are pinning it. We don't want that to happen. Same thing on the other side. We don't want to have as a requirement that the customer endpoint has to access anything. So there we also don't require it. So I hope it was clear. I know it's not an easy thing to understand. We didn't want them to have any connections to the outside to force that, and therefore this is the best solution that we designed.
Yeah, so there is also another question from Stefan Guman.
Mm-hmm.
You use certificate pinning. I think that's just what you said, indeed. So that means that you have to store all the customer certificates on the system operator side. I think that means yes.
Yes.
We have to do that.
Yeah.
The customer certificate is a self-signed certificate, question sign.
Can be or not. We didn't define that. So they can set up the certificate as they want. We are going to pin it. So it doesn't really matter. We trust that certificate and nothing else. And in the setup, of the setup of the solution, then whoever is involved in that and the process needs to ensure that we receive the right certificate for that endpoint.
I see also an open question from Mark. Does adoption of 6150 for DR greater than 1 megawatt mean that you will go as IEEE 2030.5 for smaller DR? The question is no. So you saw our presentation, and we are extremely happy with 6150. And in particular, the data modeling, but also the SCL file, and the one click or the zero touch, more or less, configuration capabilities, it's fantastic. And we are looking actually in evolution of the 6150 standard, so to say. Probably a new communication protocol, but this is something which will come later. A new work item proposal will be proposed by the Netherlands in IEC, but it's a different story. But we really would like to stay with 6150 for this use case.
I have some additional things that are happening in the United States. So IEEE 1547 is under revision and is about to allow 61850, and it looks like we will be coming up with a standardized profile using full 61850 for 1547 in the near future. So it'll be very similar to what the Netherlands has done.
Great. Yeah. And I see that Karl-Heinz Schwarz from Germany also answered on the question, and he shared also the link to a specification from Germany. I think there is one downside of the specification. It's fully in German. But anyhow, it's also describing 6150 implementation. Very good. Absolutely. I think that were the questions from the chat. Herb, then I hand over to you again.
Yeah, I'd just like to point out that this is the first of 2 DER-related webinars the UCA 61850 users group is intending to have. The next one is being scheduled, and it is from NREL to talk about their activities here. So please stay tuned on the UCA website and our LinkedIn channels for that. And I hope we can see you all in Wendell, North Carolina.